Well, thank you everybody for joining us today for Hydroterra's latest webinar. Today we're joined by Matrix Drilling, in particular Mike Mercuri and Pete Mercuri. Their topic is digging deeper from concept to completion in groundwater monitoring well installations. I'd like to point out that they're now leading as the largest number of registrants for a webinar this year. We've got over 370 registrants, so fantastic effort. This is the second webinar that Matrix Drilling have presented to us, and you can find the other one on the recordings on our website. That one focused more on drilling wells associated with waste and landfills, and feel free to check that out after this. But really appreciate having Matrix Drilling here to continue to share their knowledge today. Before we start, I would like to begin by acknowledging that we conduct our work across this great land, and for that privilege we would like to thank the traditional owners. Hydroterra respectfully acknowledges the Boonwurrung people of the Kulin Nation, where we are located today, and we pay our respects to their elders past, present and emerging. Here's a picture of all your presenters. I understand you can see us live as well. A little bit about our presenters. So Mike Mercuri received his bachelor's and honours degrees in earth sciences and environmental geochemistry from Monash University and the University of New England. He worked as an environmental officer at New England antimony mines prior to 10 years consulting in the contaminated land and geotechnical sector in Australia and abroad in the United Kingdom. For the past 16 years, Mike has been part owner and business development director at Matrix Drilling, a professional drilling services company operating in all states and territories in Australia. Mike's also passionate about his mountain bike riding and loves doing that up in the Dandenongs, and concentrates very hard on not hitting the wombats when they ride at night. Pete Mercuri, he told me that he's boringly similar to Mike, so some of the above is the same, but he has worked as a contaminated land consultant for 10 years, undertaking site investigation and remediation projects on petroleum and industrial sites across Australia before starting Matrix Drilling in 2008. Now operating 10 drill rigs across Australia, Matrix specialises in the provision of safe, high quality and reliable geotechnical and environmental drilling services to the site investigation and resource drilling sectors. So Pete's also into mountain biking. He did study at Monash University as well, but he also spent some time in Vancouver at Simon Fraser University, where he had a fantastic time. A little bit about our speakers. Before we get started, the Q&A button is how you can raise questions during this forum. I really encourage you to raise questions. We've also got, I think, a record number of early bird questions for this one, so we will do our best to get through all of those. But please raise your questions and we will read out those questions at the end, and our presenters will do their best to answer them. Why does Hydroterra do these webinars? Well, we're passionate about sharing knowledge. Our business model is about being the trusted advisors, and this certainly helps us with that. We like to facilitate education, and we work closely with research and education organisations, and we like to take an industry leadership position as we see it as important. Without further ado, I'll hand over to Mike and Pete.
Thanks, Richard.
Thanks, Richard.
For the introduction and for the invitation back. to speak. I'm mindful that we did a presentation on landfill monitoring not too long ago, the end of 2023, and that there will be a little bit of crossover. So I'll try to limit that. But at the same time, for the context of what we're talking about, there are some areas of crossover that make sense to revisit. But yeah, today I'll be, I guess, talking, or Mike and I will both be talking about why we monitor groundwater in the first instance. We'll look at some single and multiple aquifer monitoring well designs. Look at well construction materials. Importantly, things to consider before heading out to site. I think we can all learn a few things on both sides, consultants and subcontractors. We'll look at some drilling methodologies, which that's probably the main area of crossover from last time. So probably skip through that a little bit. Then we'll look at some of the guidance and regulation around groundwater monitoring well construction for drillers and for the wells themselves. If we have time, I'll talk about some of the challenges we've faced and some of the pitfalls and mitigations to those pitfalls over the years. And then we'll get into some Q&A. So we'll see how we go for time. So if you could flick to, there you go, already onto it. So why we monitor groundwater? Essentially, monitoring of groundwater provides data on quality and quantity of groundwater in our aquifers. It's an integral aspect of overall groundwater management, of a very important resource. The primary function of monitoring is to provide subsurface access for the measurement of groundwater levels and the collection of samples for analysis. The key industries requiring groundwater monitoring include domestic water supply, industrial and mining processes, but we'll be focusing on contaminated land assessments and remediation today. Types of groundwater wells. So we're focusing on monitoring wells, but they're not the only types of bores out there. There's plenty of other ones. So monitoring wells for contaminated land assessments. We have injection and extraction bores for remediation, dewatering bores for civil construction and mining. Might go to the next slide there. And then hydrostatic bores for looking at ground pressure, groundwater pressure, and monitoring and contaminant plume management for big construction sites. And then the production bores for domestic agricultural, industrial, civil, and mining water supplies.
I might add to that, Pete, that from time to time we'll also install injection bores.
Yeah.
So when they're tunneling, for example, on large infrastructure projects, and they want to keep groundwater levels stable, then we've been working on injection bores as well.
Yeah.
So this application of hydrostatic bores, so that's where if you used a conventional well, it would be artesian. Is that right? So it would actually be coming out the top of the well. Is that what that means?
I'll give you an example. So on one of the tier 1 road infrastructure projects, we installed a big network of hydrostatic bores where they were dewatering an excavation and then re-injecting into the hydrostatic bores to maintain not just water levels in the construction, but also to stop the migration of contaminants from entering into the radius of influence around those construction sites. So yeah, it's sort of a multi-purpose bore for different applications.
The water that's going into them is under pressure, so effectively it's like an injection well. Is that what we're saying? Okay.
Yeah.
Thank you.
So in terms of the basic structure of a monitoring well, we've got, well, I guess, yeah, I'll start with the fact that the majority of monitoring wells are constructed into the uppermost aquifer, and we call these single aquifer bores. And these are constructed with a well casing that you can see there, which is the blank, non-perforated section of pipe, providing a conduit from the water producing zone up to the surface. The casing is an important part of the well and assists in the construction of the bore, and needs to be of sufficient strength and, I guess, composition to withstand the pressures exerted on it by the formation, but also by other forces that are imposed on it during installation. So things like bore development and cement grouting of the bore into place. The casing needs to be, I guess, leak proof to assist with accessing the water source from the surface through unstable formations and through zones of potential and actual contamination. And the joins between casing lengths need to be structurally sound and essentially the same structural integrity as the rest of the casing itself. The types of materials that get used for casing material include PVC, steel, mostly stainless steel, and HDPE as well in some instances. Occasionally, we'll use a section of casing below a screened section, and I'll talk about that a bit later, but it's essentially looking at different types of contaminants and to identify DNAPLs, really, as to why you would put a sump in there. Sometimes it's also sometimes to catch any material coming into the well that we don't want clogging up the screen. The monitoring well screen, might just go back. I'm on this slide for a little while. Thanks. So monitoring well screen is the section of the well that's designed to allow water to enter the well and prevent excess sediment from infiltrating. Consists of a section of well casing that's usually quite precisely cut with perforations or slots. And so we call those screen slots, or the size of the slots, they're the aperture of the screen. For a typical 50mm diameter monitoring well, the aperture size is 0.4mm. And for a 100mm well, which is the typical remediation injection or extraction bores, that aperture size is 0.8mm typically. So the well obviously facilitates measurement of groundwater levels by providing a unobstructed casing to the water, and these screens need to be well placed, and correctly placed to ensure what is collected at the representative zone in the aquifer. And screen length often comes into play, and it's often a big point of contention on site during the drilling and installation process. And it, again, can quite often come down to contaminants of concern. So if you're looking at LNAPLs, for instance, and you screen below the water level, the chances of you observing a separate phase hydrocarbon are quite limited. You'll get your dissolve phase, but you won't see your separate phase necessarily. So in that instance, it's important to screen across the level of the aquifer. If you're looking, of the water table, but if you're looking for DNAPLs, you're looking for dissolve phase and what you're going to catch in a sump potentially. Screen materials are, again, PVC, but slotted, or quite often wire-wound stainless steel. And the reason for choosing different materials can quite often come down to temperatures and chemical properties of the aquifer. So I might have a quick flick through the next 3 slides.
Just before we do,
yes.
So you were talking about the slot, the size of the slot, right?
Yep.
And you said, I think it was what, 0.8 of a millimeter, did you say?
Yeah, so 0.4 typically for 50mm monitoring well. and 0.8 for a remediation well. But that can vary. I mean, the design comes down to the consulting engineer and the hydrogeologist. That if you're using a similar style of setup for a gas bore, a landfill gas bore, those aperture sizes can go up to 2 mil.
And is there any standard that needs to be referred to for the hydrogeologist, etc., when they're deciding what slot width to use?
I think there's there is guidance in the minimum construction. The 0.4 and 0.8 are just standardized across the industry, but I don't think it's written anywhere. It just seems to be the accepted level, but quite often we'll get asked for specific sizes to be cut.
In short, Richard, the larger the aperture size, the more water flow you can get into the well. And so for monitoring, you don't typically need great volumes. So 0.4 mil is enough. And it's a bit about keeping silts mainly and clays out of the well itself. So 0.4 works well at that size. I think the only guidance I know of for monitoring is the EPA guidance on the landfill gas bores, which are 2 mil to allow proper flow of gas. So, yeah.
Thanks for that.
So that's just your casing, standard casing with threads and O-rings to seal. Make sure that you kind of maintain a pretty good connection to the surface and avoid cross-contamination from...
I guess the threads are important in the sense that it allows you, it's a male-female thread that gives you like a flush inner diameter, which allows you to install, you're not going to get instrumentation caught up on lips and that type of thing.
Okay, next slide.
Yep. And so again, the same thing, but with the machine slots. And maybe the next one just shows the...
Just out of interest, I know you guys took over depths, so if someone wants to get a custom screen made, you can manufacture that. Is that right? You've got the facilities.
Yeah. So yes, so there's obviously lots of different requirements, especially for landfill, and so we're constantly getting orders in for specialized screens. So yeah, short answer is yes, you can almost do anything, and it's a lot of it's about a lot of requests are around open space or open area.
Percentage open area for the screen.
Actual spacing between the slots, right? So not the slot diameter itself, but that. Is there ever an instance where you'd be concerned, like, I guess just thinking about it theoretically, let's say you had some napple, a layer of napple, and it's less than that spacing between those slots effectively, could you get yourself in a situation where you've requested a slotting that's too wide and therefore it's going to be misleading in terms of the monitoring of it, or is that not a problem?
I think there's it's a good question. You'd get concentrations in your dissolve phase that probably indicate the presence of napple. And you'd be hard pressed to install 3 wells across a site, which is the typical number, that didn't get some form of napple. But I'd also say, some of the diurnal fluctuations in groundwater level, be it minimal, would probably see that you did get the surface level crossing over. I mean, these are, I think, 5 millimeter separations. So,
yeah, and in winter and summer, there's a change usually in groundwater levels, so there's a good chance it's going to be a very thin layer, I would have thought.
Yeah, no worries. Next slide.
Yes, please. And so that's a wire wound screen. Not used that often. And again, they're more used in situations where temperature or chemical properties in the ground preclude from using PVC. But yeah.
Well, solvents are one, aren't they, that we use them
Yeah.
for regularly?
Yeah.
So if there's concern that the solvents are going to degrade their PVC, then stainless becomes an option.
Yeah.
And you can connect stainless to PVC casings, stainless screens to PVC casings with couplings.
Yeah.
Do you construct those or you import those?
There's a company in Australia that constructs these stainless steel screens, and then there's also imported options. So it just really depends.
Is that a continuous wire around the outside?
Yeah.
Essentially.
Okay.
And they can increase and decrease the aperture size, so you can get a lot of accuracy with these ones. But they're quite expensive.
Yeah.
And that's just the image of the HDPE in a landfill setting. So a bit hard to see the image on the bottom left there. Some 10 mil perforations offset at 90 degrees across the length of that. And that's generally for leachate or gas extraction in landfill.
So they're just drilled holes, are they? Or is there slots there?
They're drilled holes, but they're machine drilled.
Right.
So we have machines set up at depths to do that as well in a variety of methods or patterns, I should say. Might move on from there. So gravel packing around the screen. So that space between the well screen and casing and the borehole wall is called the annular space. And around the screen and about 1/2 meter above the screen, typically in a monitoring well, we use a gravel pack. It generally consists of washed, well-rounded, non-calcareous sand or gravel. And obviously the grain size needs to be larger than the aperture of the slot. So for a general monitoring well, a 0.4 mil grain size, we use what's called 816, which is the sieve size, and that's a 1 to 2 mil median grain size. The gravel pack needs to be placed uniformly around, and so that there's no gaps in there. So it's important to pour it down or trim it down accurately, and have that, it's at a 1/2 meter above the screen, as I said before, sealing it. There's also a type of screen called a pre-pack screen, which has the gravel pack already placed around a screen and meshed off and tied off, so that you know that you've got your screen and gravel pack exactly where it needs to be. And we'll typically use those in soupy conditions or unconsolidated formations that are hard to guarantee a filter pack. There's a really good option there. And we use it quite often. All of our drillers have them on board, and they come in really handy. Clients typically quite happy to use those. Might move on to the next one there. So the sealing of a borehole. Again, we're just going through the typical borehole here, but groundwater wells can potentially provide a means of contamination to the groundwater by acting as a conduit from surface, or from contaminated zones above or below the saturated zone.
Do you have a like some people have that sort of finer bentonite versus the pellets, etc. From your experience, is pellets the best or chips?
It depends on it depends on the application, and it comes down to price as well. So bentonite powder is typically used to mix your grout. Chips are probably the cheapest option for sealing, with having a bentonite seal above your filter pack. But then what you see there in the picture is a time release wax coated pellet. And it's an expensive way of doing it. But again, if you're in a condition where the water in the borehole is quite soupy just from the drilling process, these things will actually, rather than float on the water and then expand and put a seal where you potentially don't want it, they'll actually sink, and you can get different rated time release. So 15 minutes to half an hour. And these things will sort of get to where they need to go, then start to swell, and then you're pretty confident about your seal being there. But they are an expensive option. Again, just something that gets brought out to site, and if it's required, it's there to use, but not
probably like 7 times the price or something, isn't it? Like
it's exorbitant.
About it roughly. Yep.
Do you deliver them through a tremie pipe?
Typically on the surface.
Sorry, can you repeat that?
Typically from the surface, and then
Right.
and then you use a dip tape to just ensure that it's in place. It's in the at the level that you want it to be at, and at the thickness that you want it at as well.
Okay.
So just in terms of bentonite, just quickly, I'm not sure everyone understands what it is, but it's essentially a natural inert swelling clay, and it seals the casing at that point. And then we also mix bentonite in with the cement, as I mentioned, in various ratios. So it's a powdered bentonite with Portland cement and water, and the different ratios just give you different specific gravities. Again, if you've got a very deep hole and it's quite soupy, you might want to produce a thicker grout, or if your borehole or your groundwater is under pressure, a higher specific gravity will get your grout down there. And then just in terms of monitoring well headworks, there's the flush mounted cover there that you probably recognize from every service station and any sort of forecourt that you've been on. But they're essentially trafficable well covers that you'll see on a road or a driveway, and then monument covers that you'll see around the place in non-trafficable areas, and quite often where there's vegetation that might obscure a completed monitoring well, just gives us a heads up as to where it is, and don't spend half the day searching for it. So I'll just quickly swing back to monitoring well design, and this time for multiple aquifer wells. So all the constituents of the well are the same, but the thing I guess to note there is that if you're trying to drill through or you're trying to drill through multiple aquifers before reaching a targeted aquifer, really need to avoid the mixing of potentially contaminated groundwater from those other aquifers. And so essentially we look at a surface casing. So you would drill down and install a surface casing into the impermeable formation below the upper aquifer system, seal that off with grout, bentonite grout, and let that go off before drilling through that and into subsequent aquifers below. So it's a pretty important one and not as common. And we'll talk about licensing and whatnot shortly, but yeah, it requires some different competency from the driller's point of view. So we might click to the next one. So well development, once a well is completed, we need to develop it. And that is by removing generally a known volume of water. And we develop a well to bring it to its maximum production capacity, to optimize the bore efficiency and stabilize the aquifer and well construction materials around it, and also get rid of suspended solids that are generated through the drilling process.
So that water coming out the side there, is that should that be sort of collected normally? Would that, like if it was a contaminated site, you'd be having you'd need to have some kind of storage vessel for
100%.
that.
Yeah, I'm glad you noticed that one. That's one of our competitors that sent me that photo. No, it's that one's a production bore on a golf course, I believe. But generally, you would capture that water in a pretty similar setup to that. But the water is diverted into either drums or IBCs if it's considered to be potentially contaminated. And you do that using airlift, which is what you see there, compressed air down a poly hose, and just being mindful of not going too hard with the compressed air, because you can damage screens and blow out filter packs and things like that. But other methods of well development include, hand baling, which anyone of my ilk, in I'm sure you, Richard, as well, in your time in the field, had to do a lot of baling. So yeah, airlift's always a nice method, and also electric pump is another way of doing it. But that is, essentially to remove the fines from the bore and just stabilize it and have it ready for the collection of representative levels and samples.
Doesn't Hydroterra have a few pumps that do that, Richard?
Yeah, look, often people talk about the Waterra pump as being quite good for well development. So
Absolutely.
they're an inertia pump. That have you had much experience with using them for that application?
I did on the
Yeah, we generally don't. So we're normally either airlift or bale.
Yeah.
The
Yeah.
consultants will occasionally, use different pumps for developing if they would like to do it.
One thing we do have is we have these electric submersible pumps that people sometimes think can be used for well development, and they come back not working anymore. So you want to choose the pump pretty carefully for that step.
Absolutely. Those pumps, those typhoons or similar, are really for moving some water out of your well to make sure you're getting some stabilized parameters prior to doing your sampling, I think.
Correct. They're more like a low flow. So just bring us up if you're thinking about doing well development, and we'll give you some suggestions on pumps and balers to do that rather than guessing. All right,
Yeah.
next
So
slide.
some other types of wells, multi-level wells. So I think I'm not sure how many people have had experience with these. They're not that common, but they're fantastic for the applications that they designed for. So a multi-port monitoring bores, specifically designed to obtain data from one or more aquifers or targeted zones within a single aquifer, but they can be installed into a single drill borehole. And it not only allows the sampling and water level monitoring of the aquifer at that point or points, but it also allows for testing of hydraulic conductivity, fluid pressures, vertical flows from one sample point, rather than drilling a network of bores. As a driller, there's only one hole that you're drilling, and I prefer to be drilling lots of holes. But from an efficiency point of view and a budgetary point of view, these are a really good idea in the right conditions. And I know, Richard, you've got a lot of experience with these. I'm not sure if you want to talk to this at the moment.
Just for about an hour. No, just briefly, sonic drilling, I think, is the best method for when you're installing these. And just like any conventional well, you still need to put your bentonite seals and that sort of thing between each section. It's very elegant in the sense that you can cut a screen length to any desired length you want, so you can really customize those lengths. So you cut a slot to the desired length, and then you wrap the stainless steel mesh around that, so you can have multiple ones of those stainless steel mesh that you can see on the right hand side there. But yep, plenty have been installed in Australia, and they're a good system.
Yeah, there's a couple of options there with the CMT and Waterloo and Flute. And I think the next slide is an example of Flute. Mike, I'm not sure if you want to jump in there at all.
Yeah, just probably pretty briefly. So these haven't been installed in Australia yet, but I'm not sure how many ports are on that picture. What is it? 1, 2, 3, 4, 5, 6, 7, 8. There's kind of 10 or 11 ports. So generally in really deep rock aquifer holes, you can deploy a flute liner and get discrete samples. you ask Flute to build the liner in the US, and it gets built to design. You just decide where you want to sample from, where you want your information from, and then it gets delivered. The hole gets drilled and it gets deployed down the hole. And I think it uses nitrogen gas essentially to pump groundwater from discrete zones to the surface. So yeah, that's the in a nutshell version.
Yep. I might just add that the engineer behind Flute, Carl Keller, is a bit of a legend in the industry, recently passed, and he'll be sorely missed. So he's done an amazing thing for our industry, and yeah, a lot of gratitude to him for what he's done. I'm going to move on to, so in situ samples as well. These are really just for grab samples of groundwater or soil gas, and they can be pushed in by hand in some instances, or used, a direct push rig can pop them in as well, but they're really just a grab in situ samples. So I thought I'd pop those in as well. But I won't.
Great, a great application where you can't get a drill rig in, so you can use a post hole slide hammer. Like anyone who's put in a star picket post would have used a slide hammer, and you use that. You can belt them into, I don't know, if you're really ambitious, maybe down to 3 meters, that sort of depth. Depends a whole lot on what the geology's like, obviously. But really good for near stream zones where you're looking at groundwater, surface water interaction. Quite a few people actually belt them into the stream beds to try and work out the vertical gradients for groundwater coming up into the streams. So really good for that sort of application.
I might skip past that one because that's just a bit of a revision of what we've done. I'll just talk about briefly, groundwater monitoring wells on contaminated sites. So some of the scenarios where we do see monitoring wells in our industry are former fuel stations, probably the main one, industrial sites, landfills, and other commercial facilities, so dry cleaning facilities, for example. In terms of fuel stations, the underground storage tank program, or UPSS, UST, that was essentially a massive program that went ahead in the last couple of decades on service stations around Australia, where groundwater monitoring wells are installed on every site to monitor for leaked petroleum products in soil and groundwater. Typically a minimum of 3 wells installed on a service station site to provide information on groundwater quality, up gradient, down gradient of USTs, and maybe looking at some different lateral flows from sources. But having the 3, you're able to triangulate using water levels to look at groundwater flow direction, and then get a bit more of an understanding about contaminant migration and the potential risks to receptors, so surface water, underground basements, and sensitive land uses on neighbouring properties. They are also used to look at vapour risks as well. You can use a groundwater well for that. Not as ideal as a separate gas well, but they can be used for that. And they're also convenient monitoring points for remediation systems. Should an assessment identify gross contamination and lead towards that kind of requirement, of installing a remediation system on site. Industrial sites, looking at all kinds of chemicals being manufactured, hazardous material spills and things like that. Landfills, it's really looking at leachate and gas, and then dry cleaning facilities are those DNAPLs that we love. They're always tricky to find. So anyone producing solvents, especially if you're in fractured rock, you've got a task ahead of you trying to assess that. I'll move on to the next one there, Richard. So just want to try and speed through this because I'm mindful of the time, but some things to consider before drilling or before attending site. And I think these are things for consultants and subcontractors and clients to that point, prior to mobilising, just to try and have a really good understanding of the site and improve the outcomes and the efficiencies of an assessment by being better prepared. So things like site conditions, can you actually get a drill rig on site? Is there space to get in? Is there a gate? Is it locked? These are things that happen quite often where you're unexpected. It comes down to planning really, but you sometimes come unstuck when you turn up to site and there's just nowhere to unload your rig, or there could be overhead power. And these are things that can be really mitigated by a site walkover, just even having a look on Google Maps to get a bit of an understanding of what to expect when you get to site. Subsurface conditions and surface conditions for that matter. So is there hard stand? Are we going to need to get through some concrete before drilling and installing? Some consultants have different subsurface clearance protocols. So some will require you to hand auger to clear for services. Others demand that it's non-destructive drilling because they don't want to risk any potential breakage of a utility. And then there's other clients who request neither. They're quite happy for you to drill from surface. So it's always interesting to know and good to know before heading out. A big one is the presence of fill on site. Is it there, and what type is it? Are you going to be trying to drill or hand auger or NDD through rail ballast, for example? That'll always tickle a driller's fancy if they're trying to get through cobble-sized ballast before trying to drill and install a well. The expected geology, obviously, is a big one, understanding what that is, and you can get a lot of information from nearby assessments. Always ask the drillers. We've done a lot of work around a lot of sites in Melbourne and Victoria and interstate, so I always ask, have we got experience there before? Bore logs from previous assessments are really handy, and then there's also online interactive maps that are pretty handy. Having an idea of contaminants of concern is a really good one as well. Looking at finding groundwater depths and whatnot. There's a lot of databases around. So the National Groundwater Information System from Bureau of Meteorology is a great one. But the Visualising Victoria's Groundwater interactive map is an absolute weapon. It's got us a lot of information over the years, and it relies on a lot of previous SOBN, state observation bore, network bores, but also a lot of the bore construction licenses that are being issued now get implemented into that database, and it's just a fantastic source of information prior to getting out to site. Just quickly on roles and responsibilities. So safety is obviously paramount, and it's a high risk set of tasks, not just one, but a set of tasks that drilling and installing a bore requires. And it's everybody's responsibility, but you need to rely on your client and your driller really to be all over their specific tasks. Sadly, there's been a notable incident recently in the contaminated land industry that resulted in an amputation. So no one ever wants to see that, and we'd like to learn and know more about these things so that we can make sure that doesn't happen going forward. But it's obviously very important to understand the hazards, mitigate those, put in controls, but also select subcontractors that hold safety at the forefront. Environmental and community impacts. There's the potential for runoff, sediment runoff, and noise is a big one. So just being mindful of that. In terms of the different roles on site, I think you can break it down pretty clearly to the placement of a well, and the well design is really in the realm of the consultant, whereas the stability of the borehole being drilled and the quality of the well construction, that really should land on the driller. So I think they're two pretty good ways of looking at roles and responsibilities. I'm going to try and, how are we going for time, Richard? Do I need to?
It's
Up a bit?
1:15, so push forward.
Yep.
We are
Okay.
going to run tight. Yeah.
All right. So look, drilling methodologies, there's lots of different ones, but the main things to think about with drilling is the type of formation you're in. So if you're in a consolidated formation or an unconsolidated formation, it'll really make a difference as to the method that you choose. So a common method or common methods for drilling in consolidated formations. So, your sedimentary, your igneous and your metamorphic rocks, rotary air and diamond core, and sometimes sonic. But then in unconsolidated formations, which we quite often find ourselves in, and typically the most challenging to construct a well into, the sort of preferred methodologies, hollow augers and sonic, and sometimes direct push, and less often rotary mud, because there's the introduction of water and potentially some drilling fluids.
So whose job is it to choose the drilling method? Is it the consultants or yours?
It's typically the drillers. Like, we'll get asked for our advice. A knowledgeable consultant will say, we're going to need air hammer out here, and it's usually because they've done it before on that site. But I think it's a smart thing to ask the question, is there a better method for doing this in a particular geology? But it's usually the drillers who will suggest it. When we're quoting, we'll say, we've suggested that, and then it's a combined decision. We wouldn't just say, no, we're drilling with this method if the consultant has another preference.
It's usually wise to have a backup method, on hand. So you might think that going out with a solid auger is okay, but maybe in consultation with a consultant, you might take out hollow augers as well, just to be sure.
One experience I've had a few times on site is just trying to determine the first time you intersect that saturated zone, at what depth, it's truly moist, is affected a bit by the method you're using. And do you have a view on that side of things?
Yep, that's I think it's a really interesting point. And one of the formations that's very troublesome is sedimentary rock, because typically you're using compressed air to fire a hammer. But in doing so, you're pushing groundwater back into the formation. And so you might not see a water strike straight away. And sometimes it can be hours, it can be overnight. And so our suggestion in those, if there's an expected water level, or if you see a change in color and it sort of looks like it might be a water strike, the best thing to do is to, rather than just keep drilling, because you may just not find it, you leave it for 15 minutes, come back. You might leave it for an hour, or you might move on to another hole, come back the next day and see where your water, if your water has come in, rather than just continuing to drill and drill and drill. It's an expensive exercise if you've already hit the water.
So low flow formations that are not kind of yielding a lot of groundwater are usually the tricky ones. So in and around Melbourne, siltstone, for example, but the drillers, especially very experienced drillers, will have an intuition, whether it's through the sound of the rig or the color of the cuttings, or just because they've drilled nearby. And so asking the driller's advice, as well as maybe talking to senior consultants in the office, are probably like, the two main things.
Yeah.
Thanks for that.
We might skip past that. It's a bit boring. Table. We might just flick through some of these. So look, I won't go into the details, but solid augering, helical flights that clear the soil by like a normal hand drill. So it just comes up up the hole with the helical flights rotating, and then it's just a bit of round and round and up and down. Then flick to the next one if you could, Richard, which is hollow augers. Same deal, but rather than having a solid pipe, you've got a tube. And so if you're in unconsolidated and collapsing materials, this is ideal. You can generally drill a pilot hole with your solid auger and then run down with these larger diameter hollow augers to install a well through the middle. They usually put a plug in the cutting tool and then knock that out and install. We'll move on. Downhole hammer. So that's essentially a percussive tool that runs on compressed air, and that sort of reciprocates and rotates to smash and blow cuttings out of the hole for penetration.
Just have to be a little bit careful with that you don't have collapse up above the head.
100%.
We used to use reverse air blast in the mining sector, and they'd always ask if you wanted to keep going. And that's something that once a driller asks the hydrogeologist or geologist on site, do they want to keep going? That's a responsibility moment for the cost of getting the rods out of the hole if it collapses. So think carefully before you say yes, be my advice.
Call your project manager for you or your junior site workers. Sonic is probably the latest in technology. Relies on vibration that's caused by these two oscillating weights in the head. So you've got rotation, but also vibration assisting, and you can tweak the frequency of that vibration. And the idea is that you find the resonant frequency of the material that you're drilling through, and it should go through like butter. And while it's a silver bullet in some instances, so landfills and tailings dams, it's not always the answer in all formations, but it's pretty damn good. So we like Sonic. Direct push. There's a system of direct push where you can get your in situ soil samples, but it's a dual casing. They call it dual tube direct push. And that's another option where you can run down, collect your samples, and then pull out your inner barrels and throw a well down through the middle of that. So that's a pretty handy one in unconsolidated materials as well. Diamond core, very much a geotechnical methodology, but does have its spot in environmental and contaminated land assessments, particularly when you're looking at fractures and particularly when you're looking at DNAPL in fractures. So knowing where those fracture sets come in, knowing their orientation and getting a really good understanding rather than smashing down with a hammer and not really understanding some of the pathways, because they can be quite complicated. And washbore is probably less used than any of those in environmental and contaminated land drilling, only because of the introduction of water and more commonly additives. So bentonite and polymers and things like that, which we typically don't want to be adding chemicals to a bore that's required for assessment. Okay, I'm going to get into, this is a bit of administrative stuff. I'll try and get through it pretty quick, but this is guidance and regulation around drilling. So the main Bible, I guess, for us is as drillers is the minimum construction requirements for water bores in Australia, which is its 4th edition. And so a lot of bore drilling and well installations are guided by this. It provides guidance on well design, drillers licensing and endorsements, casing and screens, gravel packs, bore sealing, headworks and bore decommissioning. And it's really aimed at production bores and large water bores, but it is very much used in monitoring well licensing and things like that as well. So the drillers who get license have to know all of this stuff, not just the content land side of things. there's sections in the book that are mandatory requirements, and they're actually enforceable by regulators for the protection of the groundwater resource. And drilling activities need to be conducted, I guess, in accordance with the state and territory regulations. But the main crux of it comes out of this book.
Is there a crossover in responsibility here? Like you've got a consultant that's telling you, I want to do a well like this, and then you've got a license that's saying, well, I should do it like this. What do you do in that sort of scenario?
Yeah, well, Mike and I are very clear on this. So if a driller's on site being asked to drill something, and an example would be to drill through multiple aquifers with a Class 1 license, it's the driller's livelihood. That license is his or her livelihood. So they need to make the call, and we obviously help them. We get them to call us, and we just let the consultant know that you do need a different kind of license for this. Like, it's illegal to drill with the wrong license. So yeah, it's pretty cut and dry. There's you follow the rules. Otherwise, you lose your license, lose your livelihood, and yeah, no one wants that. There is a lot of pressure though, Richard, at times. So yeah, we instruct the guys to contact the office, and we make sure that we have their back and explain. Usually it's just a matter of explaining the process.
So is there a different type of license for installing multi-levels like those CMTs and things, or is it the same license?
I think it's potentially a grey area. I would have thought you'd need a license, but what kind of license, I think, is probably something that needs to be discussed probably with the water authority.
Okay.
Yeah. So we'll just quickly run through the types of classes of driller's license. So a Class 1 license allows a driller to drill in non-flowing single aquifer systems. It's an arduous process, and a lot of these guys and girls who are drillers these days, they may not have done a whole lot of schooling, and so they get given a whole bunch of information to learn, and then an exam at the end of it. And it's pretty intense. There's a lot of maths, there's a lot of physics, there's uphole velocity calculations and all that. So it's no small feat to complete this. Like, I found it challenging, and then I find it remarkable that some of these guys and girls are getting through it with less education. So Class 2 it's all the requirements of a Class 1, but you can drill through multiple aquifers. And then a Class 3 is when you're into like an artesian or flowing aquifer system. And on top of a driller's license, Class 1, 2, or 3, you also have to have the required endorsements. And so that gives you an understanding, it gives everyone a level of confidence in your competency for drilling with particular methods. I won't go through those methods right now. So you've got a licensed driller engaged, and now you need to actually get a license for the bore. Everything needs a license, Richard. And so if you're about to start drilling a hole, if you're looking to drill a hole, you need to speak to the water authority. So in Victoria, that's the primary water authority is Southern Rural Water, and you need to get in touch with them to request a bore construction license. There's other people involved, but at that point, it's really just the water authority. Licensing requirements for a bore construction is essentially an online application, and individuals or businesses that require a new monitoring well, or anyone modifying or decommissioning or replacing existing bore, need the appropriate license for that. Southern Rural Water have quite a good online application portal, but you can still do it in paper form. But you need to provide details such as location, bore depth, the purpose of the bore, and the proposed drilling methodology. And in terms of pricing, it's pretty standardized now. So for $235, you can get a bore license to install a groundwater monitoring well, and the same goes for domestic and stock bores. They've changed all the sort of arduous and different pricing structures. So that's in
Victoria.
In Victoria, correct. Timeframes are typically a couple of days to a few weeks at the most. It usually happens pretty quickly, getting those things. And Brian Faulkner at Southern Rural Water is the drilling inspector, and he's a wealth of knowledge and a really good person to have a chat to if you've got any queries whatsoever regarding drilling and groundwater installations. One thing, sorry, go, Richard.
So sometimes people install their own wells, like with a hand auger. Just what's the trigger for needing to license? What depth or?
3 meters. So anything greater than at 3 meters or greater it requires a license, or requires the strictest of confidence. Don't tell anyone. That's a joke.
I once hand augered a well to 15 meters. Don't know if we ever licensed that. Might have been before this time. All right.
Where you got those biceps from?
That's it. That's it. Shall we move to the next slide?
Yes, please. One thing that I would just mention as well, if you take anything away from this as a consultant, is when you do apply for a license, you get the option to select observation bore or investigation bore. And it's really important that you know the distinction. So an observation bore is typically the one you want. It's issued for long-term groundwater monitoring type bores, and for use for ongoing compliance and such. If you tick investigation, there's a requirement that you have to decommission the bore before the driller leaves site. That catches people out and can really put a halt to things. So just something to keep in mind. Look, there's other reporting and obligations in terms of bore completion reports, which are pretty standard. It's on the driller, so but it's obviously just a compliance thing as well. And then if you're looking to decommission a bore, you also need a license, but that's free. And it's just a matter of going through the process, doing it right, and all that data goes into the VVG network, and helps everyone down the track. So I'll leave it at that. We've got some things here in terms of challenges and how to avoid catastrophes. It's a bit of an overwhelming title, but I'm happy to go through some of these, or we can get into Q&A. I'll let you decide, Richard.
Finish off on these lessons learned first.
So I'll just ask some of our guys for some experiences, got a few responses. I'll read out a few of what the guys have said have become challenges and where they've avoided catastrophe. So one of them is incorrect bore license type, which I just spoke about, and it sounds like it doesn't sound like it would be a catastrophe, but where it becomes an issue is if you get the wrong bore license and then you apply to decommission that bore, or you put in a bore completion report, it makes life very difficult, and everybody goes crazy trying to find where the bore is, why it's still there after 2 years, and all those sorts of things. And the authority doesn't like it. But some more fun ones, I guess. So incorrect drilling method for the site. And you mentioned this, Richard, so using air rotary in unconsolidated formations, which can result in bore collapse and burying of tools and things like that. And so the mitigation to something like that, and I'll give you an example. We're drilling at a site at the moment. It's a former quarry, dewatered quarry that's being rehabilitated. We're at about 147 meters and we can't clear the hole with a downhole hammer. We're in cast limestone, but down to 50 meters, there's sections of swelling clays, and every time you try to clear the hole, it just doesn't want to come out. And then when you do finally clear the hole and try to install the well, the swelling clays prevent you from pushing the well down. So a few things that we did to mitigate that. So we increased the volume of air. We put an extra compressor out to site that cleared the hole. And then we also ran steel casing down to 50 meters to open up that and seal off that swelling section and installed a bore and developed it, and it's fine, and it's expensive, but it worked. So that was one there. Another one that was, I'm told by the driller, it was quite an embarrassing situation. So we were requested to come and do a demonstration for a tier 1 environmental consulting firm. There were approximately 50 graduate engineers and scientists observing us at a farm in the southeast of Melbourne, and drilled to the water table, and could have installed a dry well just for the purposes of showing what it all is. But we thought, no, let's put it into the groundwater, give these guys something worthwhile. And as we did, we drilled into a very silty material, dropped the pipe in, and the soupy consistency of the water after drilling just meant that we couldn't keep the construction in the hole. And so we had 2 reasonably sized offsiders and a driller trying to hold this bore down while someone poured sand and bentonite in to try and keep the well in. And it went from being, like a nice, easy job to everybody covered in mud. And I think, made it look a lot harder than it probably needed to be. So probably not the best example to show graduates, but probably a great example of like when things do go wrong, and you can never tell what's going on in the ground. But that's probably about it. There's a few there, but we might move on to Q&A if you like. Richard, what do you think?
I did enjoy your story. I think we should move to Q&A. But thanks very much for that. Just to let you know, Mike had to take off at 1:30, so I really appreciate, Mike, if you've left.
I haven't yet, but I'm just about to.
So many thanks for attending.
Thanks everyone for coming along. Thanks for hosting, Richard.
Pleasure. And Pete's going to hang around for the Q&A, which we will continue. Those of you who need to leave, we will be recording the Q&A session as well, so you can always pick it up. The recording will be up on Monday, but please stick around if you can. All right, so we have lots of questions to answer. Early bird questions. Right, you ready, Pete?
Yep.
Can we force geotech companies to require licensed water bore drillers for monitoring wells to log them with the government department?
Yes, because it's the law. So you have to. That's all I'd say to that.
Good first question. Should there be an Australian standard for groundwater monitoring bores?
I agree that the existing guide is loose, and it's a great idea. When it comes to contaminated land, the drilling industry itself is pretty loose. I guess in that it's somewhat unregulated compared to other trades. I think a fair bit of work needs to be done to get the standards up across the board. And I think if somebody was willing to take that on, I think it'd be a fantastic result to get a standard.
I'd say here is it sits between 2 worlds. So we do have the national industry guidance that's been prepared by the Australian Hydrographers Association, and the Bureau of Meteorology's got some involvement there, which does cover quite a bit of this. And then it sort of comes across to your drilling standards. So it might be about clarifying the overlap between those rather than starting from scratch. So it might be something worth us looking at.
Absolutely.
Next dot point. What is the usual process if your Class 1 driller hits an unknown artesian aquifer and water discharging from your borehole?
Yeah, that's a challenging one. We've had that happen in Port Melbourne, where we've hit pockets of methane, and it's started blowing methane and groundwater out of the hole. And I have to give kudos to another driller who came and helped him out at the time. Chris McMullen came and grouted that one up for me because he had the right equipment and the right know-how at the time. It was probably about 15 years ago. But look, the short answer is to stop drilling when that happens and to contact the water authority. So you would typically contact Southern Rural Water. If you have the ability to seal the well off, whether that's by sealing off at the casing at the top, that would be a really good thing to do. But quite often it's an open hole. You don't have a casing in there. So yeah, the next step is generally going to be to pressure grout it. So mix up a really high specific gravity grout and pump it down there, and then go and I guess back to the drawing board and work out what you need to do. And there'd probably be a requirement for a class 3 driller to come out and supervise or actually undertake that sealing off of an artesian well.
Sounds like something to avoid. Next question. Should we be getting slug tests on every bore we install?
Yeah, so I mean, it's an interesting one because my understanding is that slug tests, they're a tool that you use to characterize the hydrogeological conditions. And that's typically used in contaminant transport studies and remediation system design rather than your stock standard monitoring well assessments. So probably not always necessary. However, having more hydrogeological data is always good, I think. So yeah, it'd be very useful. Don't know that the clients would be willing to pay for it, but yeah, certainly would be useful.
Right. It would be really valuable if you're trying to build a numerical model or something. How to avoid installing a dry well when the water strike looks different in different geologies?
Yeah, so we sort of spoke to that a little bit before, I think. So
yeah, I think
we spoke to the hammer tied to the compressed air being used as your drilling fluid. And so therefore, in that instance, I think waiting, like turning off your air and waiting, you go and have morning tea or lunch, and then you turn your air back on, you might see some water, some moisture, if not, some flowing water coming out of the bore. Where it's challenging and, where you rely heavily on driller competency is when you're using water itself as a drilling fluid. And one of the ways that I know the competent drillers do ascertain water strikes is when they can essentially see whether they're losing water to the formation. They sort of know that they're probably not in an aquifer. If their water is staying at the same level in their mud tank, that is, or they're gaining water, then that's a pretty good indication that they're in a water bearing zone. So that'd probably be my suggestion to that, is to look to monitor your water, the water coming into your hole.
very good. Are there any additional considerations that ought to be made when installing wells for remediation purposes?
Yeah, look, I mean, we haven't sort of probably discussed a lot of the considerations, to be honest, about remediation wells, but in terms of, from an initial perspective, you really want to look at the proposed use. Like, is it an extraction bore? Is it an injection bore? So that'll determine slot aperture, borehole diameters. Is there any instrumentation going down the bore? Again, you might have a 4-inch pump, and then you go ahead and install a 4-inch well or 100 mil well, and the pump doesn't fit because you needed a 125 mil well. So those are the sort of considerations that ought to be made when installing them. And also required yield. So if you're dewatering, for instance, you want to know how much water you need to move, and that might, determine the diameter and number of bores that you might want to be popping in. So that's true. If that's,
I think that's a point worth reiterating, is the well diameter does have a whole lot of consequences, particularly for monitoring side of things. So quite often people contact us after they've done their well installations and say, oh, do you have something that can measure X, Y, and Z? And we go, sure we do, but it's going to need a 100 mil diameter hole, not a 50 mil diameter hole. So having those chats up front is really important before you start putting your wells in.
Yep.
Next question. What are the options for repairing old or damaged wells? We tend to opt for reinstall. Is there a more cost-effective method?
Yeah, look, it depends on the level of damage. If the damage is, more than a few meters down the hole, then there's not a lot you can do rather than just decommission and replace, which I know it's a really expensive way of going about it. But I guess if you had an old water bore that was cased with steel, you'd probably feel confident to run drill tooling down it. But if you're running down, say, a PVC well, like you're just as likely to compromise the existing infrastructure and then create problems with surface water being able to get migrate down the well. So it's like a builder starting on a half-built house. That you typically won't find someone do it. They'll just want to start again and know what they're dealing with. So if it's a structural issue near surface, you can typically dig down and rectify some issues, and we do that quite a bit. But unfortunately, the replacement is probably the majority of the time.
Right. What is the best approach technique to develop deep water bores? For example, a bore 300 metres deep with a water level at 150 metres below ground level.
That's a really good bore, I reckon. It's 150 metres of head. That's fantastic. Look, more air is probably the answer, more volume of air, not pressure. So a 200 to 250 psi amount of pressure is probably the right amount, that you're not going to blow out a well pack, a filter pack, or actually destroy the screen. But it's more about the volume of air. So adding a compressor, which is what we did out at this site that I mentioned before. It allows you to clear, but you need to be mindful of not damaging the well itself. So I would say add more air, and talk to somebody who understands their uphole velocities and things like that.
Or development practices. That's just a statement. I think we covered that. Some options.
Yeah. So I mean, best practices are, like in our industry, I think, is 3 well volumes, and that might not be enough. You want to see your water come clear, essentially, if it will. But 3 well volumes. So if you've got 3 meters of water in a 50 mil well, there's 2 liters per meter, so you're looking at about 18 liters. So if you pulled out a bucket of water, a 20-liter bucket of water, you've probably reached what is considered industry practice. But it's really up to the individual. If it's still dirty, you might want to keep pulling water out.
All right. Next question. How does environmental monitoring well differ than the SI monitoring well in terms of method and depth? What do they mean by SI, do you know?
I assume that's like a piezometer on a geotechnical assessment. And they're very similar. They should be installed by a licensed driller. If you're interacting with groundwater, it should be a licensed driller installing those. Historically, it hasn't been, but we're getting a lot better at going, using the right licensed people to do these things. But it should be exactly the same, essentially.
Screen length in fractured rock aquifers with very minimal flows could be interesting, and digging shallower when water is 0 to 7 meters below ground level. So
I'm not sure what the question is there.
I think there's two questions. So the first question is, how do you determine your screen length in a fractured rock system with very small flows?
Yeah.
Any thoughts?
Yeah, look, I've got a pretty long answer to that, which I'll try not to go into. But if you can work out where if you're looking at contamination and say you use the flute liner to work out where your contaminant was coming in, then you can screen across a very small amount of fractures rather than across a large amount of fractures and introduce mixing of clean water with your contaminant. Yeah, I think that's probably more for the hydrogeologist to determine screen length and what they're really trying to target if they're trying to be specific, but you can go as small as you like.
Yeah. The second part of that about digging, I might talk to that one. So sometimes you've got cobbles and that sort of thing that just get in the way of traditional drilling techniques. You can use a backhoe, for example, to excavate a pit to put in a casing. I've been forced to do that on some sites. Have you had to do that, Pete, on some sites?
Yeah, yep, we have, particularly in tank pit monitoring wells.
So keep that in mind. So how do you, in that instance, I always sort of was a little bit curious about the construction after that, right? Because you're sort of dealing with a very different shaped hole. What's your view on how you finish off the construction of a well where you've used a backhoe to dig a hole?
Yeah, so you essentially put a conduit in that hole and then backfill around it, so you can actually get the rig to the hole and work safely around the excavate rather than have an excavation. It's a level bit of ground again. Set the rig up over that and continue drilling as if you've essentially just cased the hole from surface. So that's usually how we would do it.
You have some other ways we did it back in the day. All right, next dot point. What additives are suitable for drilling boreholes through rock when wells are used for contamination sampling?
So in rock, you should really only have to use water, is my view. But there's times where you'll come in and out of other formations potentially. So if you do need to increase the viscosity of your drilling fluid to get cuttings to the surface, then maybe start with natural additives like bentonite. And then you're going to develop the bore anyway, so you hopefully develop the majority of that out. But if you need to go to polymers, then there's biodegradable options again, which you would develop out. But probably the key is that if you introduce anything, then maybe note that. And when you're looking at your analytics and you see something in there that sort of looks remarkably like a polymer, then you might be able to say, that's where it's come from and explain that away. But yeah, I think if you can avoid adding anything other than water, you're probably going to be in a better position.
All right, groundwater monitoring for a wastewater disposal area. I think they're asking what sort of wells would you use?
I think just your standard 50 mil for monitoring. If you're looking to extract, then maybe something a bit bigger, but yeah, just a 50 mil. Well, and I'm guessing that if it's a ongoing environmental compliance thing, then yeah, you'd want to have something permanent in there. So 50 mil standard well.
I guess there's a bit more of an added consideration about making sure your surface seal is really robust.
Yeah.
Where they might be irrigating wastewater.
Yeah, absolutely.
Okay, next one. I would like to learn more about well development techniques, particularly for deeper wells installed following rock coring. We've covered well development. Do you think, was there anything you wanted to add to that, Pete, or you felt that we covered it?
Not really. So, I mean, if there's anything more specific, like feel free to reach out. Whoever asks that, I can try and answer more specifically to your your question, but yeah, I think we've covered it. It's usually air and more air.
Drilling of bore clusters when targeting multiple aquifers, termination requirements, additional considerations, etc. I know you covered a bit of that.
Yeah, so those multiple bores or multi-level samplers. I think you've got to choose between that, and then it might be down to available space. You might choose multi-levels if you don't have a lot of space to drill a network of different level bores. Yeah, one thing I'd add is that we discussed licensing around multi-levels. I think if you were drilling through multiple aquifers, you'd need a Class 2 license. So just keep that in mind. I think that's the stance of the authority if you were doing that. But yeah,
Class 2 or Class 3? Oh, it's Class 3.
Two if you're going through, unless it's artesian. So Class 2 for multiple aquifers.
Very good. Next question. What aspects of planning are often overlooked by consultants and principal contractors before arriving on site?
Yep. So probably the main two are licenses, by having the right license, and then site conditions, just turning up and not having an understanding of the things that we spoke about before turning up to site. So just having those kind of and a site walkover really makes light work of those sort of issues and can really improve efficiency.
Responsibility of the underground services?
Look, it's generally the consultant. In all honesty, I think we're all responsible to make sure that we don't damage it. But ultimately, it's the client and the consultant who do the legwork in identifying by engaging service locators and dial before you dig and whatnot. We do that occasionally. I know there's other drillers who do the same. They'll get their own or other service locators in. But it's probably a combined responsibility, but ultimately it's on the client.
What are the instruments used to conduct this test, and in your country, what relevant government rules must be followed? Not sure what they mean by that.
Sure what specific test they're referring to there.
We might skip over that. How do you determine what contaminants to monitor? I think that's a big discussion. That's sort of your more contaminated assessment guidance.
Yeah.
Let's move to the Q&A. You happy to keep going, Pete? Got a bit left in you?
Yep.
Doing very well. Now, how do I, for some reason, that window is not showing for me. There it is. All right, 19 questions to go. Here we go. First one from an anonymous attendee. The 0.4 to 0.8 millimeter aperture is pre-made or to be cut on site?
That's pre-made.
Okay, very good. John Simons. Depends on materials being screened. See groundwater and wells. Sterrett, edition 2007. So I think that was relating to my question about the width of the slots.
Yep.
Martin O'Rourke. Good question, Richard, about thin DNAPLs and horizontal slots. There you go, Pete. Staggered vertical slots instead of horizontal slots would fix that issue. Yeah, so I guess an angled slot or is probably the way to go there. Next question. Just need to move down this a little bit. Anonymous attendee, hi there. I was wondering if detection of vinyl chloride in the groundwater could be due to the UPVC used for the water wells, or it's highly unlikely. Especially if the tube was stuck midway and was hammered down, might have been scraped, so there might be microplastics in the groundwater sample. I think they're talking about cross-contamination from PVC casing.
Yeah, look, I mean, it's an industry standard product, but that doesn't mean you can just hang your hat on it, does it? So I think it's relatively inert, the PVC, UPVC, but I couldn't tell you off the top of my head if there's been studies into leaching of vinyl chloride from the PVC itself, but it's certainly an interesting point. Probably something we need to do, throw a screen or a casing in a bucket for a few days and then sample the water, see what we get.
The US EPA early on, so this would be back in the 1990s, did a bunch of tests like that. And that's how the industry ended up sort of settling on things like the PVC. So it's worth checking. So US EPA, you could Google that, plus something like casing, leaching, and you'll find a few studies on that for sure. Next question, anonymous attendee. Can the ceiling packing be replaced with just geotextile liner? So I think that's referring to replacing a bentonite seal or a sand filter pack, gravel filter pack with just a geotextile liner.
It's not industry practice, I guess, but I mean, there's no reason why. Again, there's no nothing to say that wouldn't be sufficient. I guess the swelling nature of the bentonite, really, you're getting all the nooks and crannies around the well and into the formation sealed off. So yeah, look, if you could put your hand on your heart and say that the geotextile or geofabric material is doing as good a job, then why not? I don't know how you'd place it at depth, but yeah.
Yeah, I'm sort of visualizing having to cut a whole lot of donuts of geotextile to place down there.
Yeah.
Interesting question. Probably the short answer is no, wouldn't do it. Just using geotextile. There are various pre-packed things, like Solents make a pre-pack for their CMTs and includes like a bentonite one that straps on the outside of a CMT. It's like a capsule and it's got the bentonite sort of pellets stuck into the side of it, which is quite effective. They also do the same with a pre-made sand filter pack that you can strap to a casing. So I've certainly seen some of those things done before. Yeah, so there's options. Next one, anonymous attendee. Bentonite seals break down in brackish to saline water. It's a good point. Just scroll down a little bit. A small length of grouting directly above the gravel pack, let it cure and then grout to the surface would fix that. So bentonite's a swelling clay. And sometimes those swelling clays can be affected by the ionic composition of the water, affects the ability for the lattice to swell. Have you got an opinion on that, Pete?
No, it's a really good point. And I know when we're drilling in saline conditions, when we're mixing bentonite as a drilling fluid, we switch to products that are better suited to saline conditions that will still activate. So maybe, yeah, I mean, there's a lot of wells out around the ports and places where you would have that brackish water. So a really good point that maybe could improve the standard that you use a more saline friendly bentonite to ensure you activate that bento and make it swell in those conditions.
Is it possible to reverse and go the other way so it becomes more permeable? Like I've seen that before on landfill caps where you've got a geotextile with bentonite in it. And there's certain solutions that affect its permeability. I mean, maybe I'm just talking to myself there. Let's move on. Do you prefer to develop to 3+ well volumes with low sediment or to stabilization of parameters?
It's probably a question for the consultant. When I was a consultant, we were punching out lots and lots of wells on lots of service stations, and so it had to be standardized to, but I think the preference is to develop as much as possible. But you certainly, before sampling, you want to be seeing your parameters stabilized. Like you wouldn't sample otherwise, because you don't know that you're getting representative samples of the aquifer. So you certainly want a stabilizing of parameters. And the 3 well volumes is just a standardized thing across the industry, I think, to make sure that people are actually doing something.
Yeah, that's right. Achieving stabilization is a lot more definitive, that's for sure. Next question, is there a contamination risk during the drilling between 2 aquifers, or does any potential cross-contamination during drilling will be removed during development?
It's a really good question, because there's a line of thinking that you could essentially drill an open borehole through your top aquifer into a lower aquifer and install in a timely manner, and thereby sealing off that top aquifer, and then the development of the bore would essentially remove any contaminants. I think the idea is really that you don't risk getting the contaminants down there in the first place, because if it's a DNAP or some sort of tar that's going to stick around for a while and not develop out necessarily that easily, then the idea is to case off into an impermeable. And look, we say impermeable, but it's always an aquitard, or isn't always. It might be semi-permeable. So yeah, look, I think casing off, letting the casing set, and then drilling through is definitely the way to do it if you want to get really good representative samples of the underlying aquifer.
Okay, next question, Jaden Pan. What benefits does sonic drilling provide that cannot be achieved with other, more conventional drilling methods like diamond core or mud rotary?
Yep, so sonic drilling can give you large diameter cased holes quickly, essentially. And so you can install through, and you also get really good representative samples of the material you're drilling through. So you have an inner barrel, which is similar to a diamond core barrel, but as you push down through the material, you get to see exactly what you're drilling through. And you end up with a really nice cased hole, rather than potentially an open hole or having to casing advance a diamond core. So yeah, you get good samples and you get a cased hole fast, but you pay for it.
All right, next question is from Matthew von Snarski. Groundwater monitoring wells are required at every new service station. Why are none of these ever logged or drilled by licensed drillers? Or is it just the local drillers and geotech companies here in Queensland that don't follow the rules?
It could be, it could be that. I don't want to throw anyone under the bus. You might be, Matthew, you may be referring to tank pit monitoring wells, which don't require a licensed driller because it's installed into an existing excavation and then backfilled. Monitoring wells certainly should have licensed drillers. Having said that, there's rules in New South Wales that differ vastly to Victoria, where you don't need to have a groundwater license as such for the bore, but you still need to have a licensed driller. And there's a lot of cowboys out there as well. So yeah, probably a little bit of both.
Question by Simone Sakamoto. Is there a New South Wales similar portal to visualising Victoria's groundwater?
I believe there is a New South Wales database. I don't have it off the top of my head, but I might, if Simone, if you'd like to message me directly, I'll take a look and get back to you about that.
Then Matthew von Snarsky. Queensland does not require a license to drill a stock or domestic bore.
Okay. I wasn't aware of that. That's very interesting because that's, it sounds pretty unregulated. But I think he then goes on to say that it's 6 meters in Queensland, so that it might be that it's not required above 6 meters, which
Up till 6 meters, yeah.
Yeah.
All right. Well, there's a little red flag just to check what your rules are in Queensland for anyone doing a well up there. Next one, an anonymous attendee. What are the implications of having a gravel pack 1 to 2 meters above the screen instead of the recommended half meter? Would this be a significant issue if the gravel pack remains within the targeted aquifer and 0.5 meters of bentonite is still placed in the well? If the borehole walls collapse after the screen and casing are placed in the borehole, can the collapsed material act as a gravel pack?
Yeah, look, I don't see in that instance, I don't see there being too much of an issue. It is a guide. I think the 1.5 is, probably it's a good minimum. But there's times where you're installing wells near surface where you might only have a 20 centimeter or 30 centimeter sort of gravel pack above the screen, just because you literally don't have the space to do that and get a seal in. So in the instance that that questioner has specified, I don't see there being any issue as long as you get a seal in between the targeted zone and a potentially contaminating formation above. I think you'd be fine.
I think it's just worth remembering that your filter pack is effectively becoming your slotted section, right? So water's going to be entering that well from your filter pack as well as from the screen. So any conclusions you make about the water quality that you've collected, you need to be thinking across that wider interval, not just the slotted screen interval. So I have seen that mistake made before. So it's important in terms of the conclusions you're making. Oh, sorry, got bombarded by a system. Martin O'Rourke. Oh, sorry, I missed one. Ooh. Another one from Matthew von Snarsky. The favourite polymer additives used in mud drilling and the required cleanup chemicals have warnings on the drums that they are toxic and do not allow to enter waters, wastewater or soil. When will these chemicals be banned from drilling and installing groundwater monitoring wells where parts per trillion are important? How can we best assist consultants to never ask drillers to dual purpose a cored hole to a groundwater monitoring well?
Yeah, well, I mean, in our experience, the consultants are always very, very interested to know what we're putting down the hole. Even if we're putting clean water down, they want to know why you're introducing that. So if you're drilling a monitoring well for sampling purposes, as a consultant, you want to be all over what's going down there. You want to have the the safety data sheets on those things and know what you're putting down there. And if nothing else, just be aware when the analytical results come back, what to expect from something that might have gone down the hole. But you realistically shouldn't be putting anything down there unless it's water anyway, if possible.
Okay, sorry, the Q&A goes up and down a bit today. Martin O'Rourke. It looks like I think he's reflecting on your story. There is nothing a job going wrong. Nothing, I think, means like a job going wrong in front of a bunch of students to show just quickly how a job can go pear-shaped. An excellent learning experience for young minds. Simple jobs that go well can give a false sense of security. So well done there. Pete, that's the most magnificent training you could have given. And then another one, a shame you can't edit. There is nothing like it. Oh, he's
Same one.
same one again. Thanks, Martin. Okay. The next one from an anonymous attendee. Hi, Pete. Thanks for the presentation. Really informative and detailed. Can I ask, regarding your interesting position being both a consultant and a driller throughout your career, can you speak broadly regarding maintaining clear communication between both drillers and consultants, given you are aware of what each party needs to know?
Yeah, look, I think I speak about that a lot when I'm marketing our business and the crossover. So I'm more than happy to have a chat. And if you would like me to come in and have a chat to your company specifically, we do that quite often. Yeah, it's a nice place to be, to have that knowledge of both worlds and to know the constraints. And we're very mindful of the constraints that consultants are under, and that our job as drillers is to provide a service and hopefully do it with a smile and enjoy it, rather than making life any more complicated for a very complicated role that being a consultant is. So more than happy to talk to you about that specifically, or if you'd like me to come in and speak to your office, I'd love to do that.
Excellent. Next one from an anonymous attendee. Drilling muds are costly to manage. Will Matrix be looking at innovative, sustainable ways to in situ manage contaminated soil derived from drilling process?
Yep. Look, it's part of our business. So I guess, and it's a large part of our business, is disposing of the waste that we produce. Because at the moment, there isn't a great way to, I guess, justify putting drilling muds back on site with the potential that you're contaminating that site. And generally your assessment is to look at how contaminated is the site. You don't want to be adding to that by putting other waste products on there. Certainly, there's technologies out there that are getting better and better in terms of waste management. Yeah, look, at this stage, I'd always welcome any information about technologies that we could utilize, or places where we could take our waste that would be more sustainable. And yeah, if it stayed on site, it'd be even better. But I don't think we're near that at the moment as an industry.
Okay, next question, anonymous attendee. In New South Wales, borehole information can be found here. So we've got a couple of, so there's realtimedata.waternewsouthwales.com.au/water.stm. There's waterinsights.waternewsouthwales.com.au, and groundwater sources, datasets.seed.nsw.gov.au, dataset water sharing plan, groundwater sources spatial dataset. So that really related to the earlier question about where we could get data in New South Wales regarding similar to the Visualising Victoria platform. Probably need to think about how we could circulate that information a bit more out to the general public. Perhaps all the regulators on board, if you want to shoot us emails with how people can get that information, we could shoot it out to the broad audience. Next question. Do all monitoring wells follow the same standard 50mm pipe diameter for installation? What instances where you would use a bigger pipe diameter and thickness monitoring well installation?
Yeah, typically the 50mm, is what we use. That's what we're asked for. Seems to be the industry standard. I assume it's come from something like what you mentioned about US EPA, Richard. Probably coming up with an idea that 2-inch borehole diameters were sufficient for quantity and quality of samples. Occasionally we get asked for different types of PVC, so like American style PVC quality. So I think they call it it's like an 80, like a standard 80 size, but I think 99% of the work we do is with 50 mil. 100 mil, as we mentioned, is quite often for remediation wells, because you're able to extract and inject higher volumes. But yeah, look, I think 50 seems to be the standard, and my understanding is that's Australia wide. Sometimes you go to 25 mil. That's a very, very rare occurrence these days, though. It used to be a bit more common, but yeah, not like I can't remember the last time we put a 25 mil well in.
I think maybe a bit of guidance here would be if you talk to someone like Hydroterra about what you're needing to measure, and we can give you some indication of the diameter of well you need to fit measurement devices in or pumps, etc. And then get the guidance from the driller once you know that information. I think it's not a bad way to go. Believe it or not, Pete, we've got to the end. I think it's close to a record. You and Phil Mulvey, you might be neck and neck there. But really appreciate your attendance here today. It's been fantastic and really informative. I've certainly learned a lot. And still got about 60 odd people here, so a lot of people appreciated what you've done there today. So many thanks. It was really informative. If people want to get hold of you, they just look you up at Matrix Drilling on the website. Is that right?
Yep, absolutely. I'll welcome any further questions. Yeah, and like I said, more than happy to come in and speak to you as a group at your office. We do that a lot and find it pretty helpful for crossing that divide between the consultant and the subcontractor. So appreciate being invited back again, Richard, and your team. And yeah, thank you so much for everybody who attended, and enjoy your weekend.
Thanks, Pete. See you, everybody.
Bye.